February 15th, 2026. In under 10 hours, Hawaii's Kīlauea volcano launched rivers of molten rock over 1,300 feet into the night sky, turning Halemaumau crater into a cauldron of fire and sending ash and toxic gases billowing for miles. Scientists raced to decipher real-time pressure surges, while civil defense teams weighed evacuation plans for communities downwind. But how close did this fire in the sky come to disaster, and what danger still lurks beneath Kīlauea right now? At precisely 1:50 in the afternoon on February 15, 2026, Kīlauea's Halemaumau crater erupted with a sudden, violent force. Within minutes, two vents at the summit hurled molten rock skyward. Lava fountains soared as high as 1,300 feet, matching the height of a 4-story building stacked atop the Statue of Liberty. The eruption's intensity built rapidly. By 3 o'clock in the afternoon, both the north and south vents reached their peak, unleashing a combined torrent of molten rock at nearly 1,000 cubic yards per second. The sky above the crater darkened as ash and volcanic gases climbed to 35,000 feet, drifting on shifting winds and casting a haze for miles. For relentless nearly 10 hours, Kīlauea maintained this pace. The fountains roared, lighting up the crater and sending heat waves across the park. Scientists at the Hawaiian Volcano Observatory tracked every tremor and tilt, watching pressure readings spike and then plunge as magma surged upward. Civil defense officials monitored alerts, ready to warn communities if the eruption spread beyond the park's boundaries. At 11:38 at night, the fountains finally fell silent. In less than a single day, the volcano had covered half the crater floor with fresh lava, leaving behind a landscape transformed and a sense that the danger was far from over. Kīlauea's latest eruption stands out not only for its spectacle, but for how it fits within the volcano's long and varied history. In 1959, the Kīlauea Iki eruption set a benchmark with lava fountains soaring to 1,900 feet, still the highest ever recorded at the volcano. That episode lasted several days, with bursts of intense fountaining separated by quiet pauses, leaving behind a deep lava lake. The 2018 eruption, by contrast, unfolded on the Lower East Rift Zone. It stretched over months, destroying more than 800 homes and forcing mass evacuations as slow-moving lava flows crept through entire communities. That event produced vast fields of fresh rock, but its fountains rarely approached the heights seen at the summit this year. What makes the February 2026 episode remarkable is its combination of brevity and power. In less than 10 hours, Kīlauea released a torrent of molten rock that rivals the tallest bursts of the past, yet the eruption remained confined to the summit crater. Unlike the drawn-out crises of 2018, this was a concentrated surge, high volume, short-lived, and closely watched. Such rare, intense episodes remind scientists and residents alike that even the most familiar volcano can deliver surprises. The scale and speed of this event have prompted new questions about what Kīlauea is capable of, and what dangers might still lie ahead. Ash began to drift across the island within hours of the first eruption, settling on rooftops, cars, and crops in communities like Pahala, Punalu, and Na'alahu. Fine volcanic particles carried on the wind-coated windows and left a gritty film on outdoor surfaces. For residents and visitors downwind, the air turned harsh and acrid. Even light ashfall can irritate eyes, scratch throats, and trigger coughing fits, especially for children, the elderly, and anyone with asthma or heart conditions. But the ash was only part of the danger. Volcanic gases, especially sulfur dioxide, mixed with moisture in the air to form VOG, a dense, hazy smog that spread for miles. VOG can push air quality into the unhealthy range, forcing people to stay indoors and close their windows. Farmers worried about crops and livestock as plants wilted and animals showed signs of stress. Civil defense officials urged residents to wear masks, avoid strenuous activity outside, and keep a close watch on local alerts. Closer to the crater, the threat was even more immediate. Ballistic rocks, chunks of solid lava blasted hundreds of feet from the vents, posed a lethal risk to anyone venturing near the eruption site. Park rangers closed trails and roads leading toward Halemaumau, warning that even experienced hikers could be caught off guard by falling debris. One public health official on local radio described the situation bluntly. "If you can see the plume, you are too close." With each hour, the eruption's fallout forced communities to adapt, reminding everyone on the island that Kīlauea's power extends far beyond the crater's edge. Ash from Kīlauea's eruption did more than cloud the sky and sting the lungs. Fine volcanic particles, some almost invisible to the eye, drifted far beyond the crater and settled onto roads, power lines, and water catchment systems. Even a thin layer of ash can short-circuit transformers, clog air filters, and corrode metal surfaces. For anyone relying on rainwater, contamination became a pressing concern. Ash washed from rooftops into tanks, leaving water supplies gritty and potentially unsafe. Air travel faced its own set of dangers. The eruption forced the Hawaiian Volcano Observatory to raise the aviation color code to orange, a clear warning to pilots. Volcanic ash is not just a nuisance for jet engines. It acts like sandpaper that scours turbine blades and melts into glassy deposits, which can choke airflow and cause engines to fail. With the eruption's plume climbing to 35,000 feet, well within cruising altitude for commercial flights, airlines had to reroute planes and stay in constant contact with air traffic control. No flights reported direct encounters this time, but the risk was unmistakable. The threat extended underground as well. Ash and acidic gases filtered into the soil, raising alarms for farmers and water managers. Crops can wilt, and soil chemistry changes, sometimes for months after the last fountain dies down. Every layer of fallout left behind by Kīlauea's outburst reminded the island that the effects of a volcanic eruption ripple far beyond the immediate blast zone, touching every part of modern infrastructure. Inside the Hawaiian Volcano Observatory, a bank of monitors flickered with live data as the eruption roared outside. A sharp drop in the Uekahuna tiltmeter, 33.7 microradians of deflation, confirmed what scientists suspected. Seismographs captured a spike in volcanic tremor just before the fountains burst skyward, while gas sensors tracked the sudden rise in sulfur dioxide. Every instrument pointed to the same conclusion. Pressure inside Kīlauea's summit chamber had reached a breaking point. Throughout the 10-hour eruption, HVO scientists watched the effusion rate climb to nearly 800 cubic meters per second, a torrent of molten rock few volcanoes can match. Real-time measurements guided every decision. The moment tremor readings soared and the tiltmeter plunged, officials moved quickly, issuing a watch alert and raising the aviation color code to orange. This was not just for pilots. The code signaled to emergency managers and residents alike that conditions could change at any moment. For the team at HVO, these numbers were not just data. They were the backbone of every warning, every public message, and every plan to keep the island safe. Pressure inside Kīlauea's summit chamber is already on the rise again. Scientists at the Hawaiian Volcano Observatory track every subtle shift, a slow inflation of the crater floor, a renewed glow from the vents, and a faint but steady uptick in volcanic tremor. These are the signals that matter most. When they appear together, they often mean magma is moving upward, setting the stage for another eruption. After February's episode, the tiltmeter rebounded quickly, hinting that the volcano could recharge in as little as 2 or 3 weeks. Civil defense officials remain on alert. Their spokesperson reminds residents that while the last eruption stayed inside the park, the next could bring new hazards. Emergency plans are ready if alerts change. Air quality warnings, road closures, and, if needed, evacuation routes for nearby communities. The focus now is on vigilance, watching for the trio of triggers that have preceded every recent outburst. As the ground swells and instruments flicker with fresh activity, the island waits, knowing that Kīlauea rarely stays quiet for long. Kīlauea's eruption hurled lava 1,300 feet high and sent toxic clouds over Hawaii in just 10 hours. Today, scientists still track every pressure shift because the next eruption could strike with no warning. Living here means living with uncertainty every day. Stay vigilant. Share your thoughts below.